So in this quick video, we're going to talk about what a monopoly diagram looks like and what profit maximization looks like for a monopoly. So don't forget the big difference between monopoly and perfect competition. In perfect competition, there were many firms, many buyers, homogeneous goods, meaning all the goods that all these different firms are selling are relatively the same. And then finally, free entry and exit. So firms could freely enter or exit the industry. This is different than monopoly, where there's just one firm. Scroll down a bit, and there are barriers to entry. And in class, we talked about different types of barriers to entry, whether it's ownership of a resource, whether it's like a government-imposed monopoly, whether it's a natural monopoly, etc. So when we're comparing these two different industry types, or market structures, I should say, perfect competition, firms are all price takers. So they had this flat marginal revenue curve, this flat demand curve for individual firms, because they could sell as much as they want for the same price. This is going to be much different than monopoly, where there's one firm and they get to choose what price they want to sell it at and how much to produce as well. So they get to choose both price and quantity. The other difference is that there are barriers to entry in monopoly. So even if other firms see a profit, an economic profit in this industry, there's something that's stopping them from entering. So let's take a look at what a diagram will look like for a monopoly, a profit maximizing monopoly. Okay, so now we just need to draw one diagram. So in perfect competition, we drew two diagrams side by side, right? We drew the industry as a whole with a big supply and demand curve that determined the industry price. And then each firm was on that right diagram where they took that industry price as given and then made these profit maximization decisions where producing our marginal revenue equals marginal cost. Now we only need one diagram because the industry is the firm. So this is the firm or the industry or the market or whatever you want to call it. It's all on one graph or one diagram. Okay, so we have this downward sloping demand curve. So it follows the law of demand. So it's downward sloping. It's the market demand curve. And now we have this steeper marginal revenue curve. So this marginal revenue curve is steeper than the demand curve because assuming this is a one-price monopolist, that is, they can only charge one price to all their consumers, to sell more of the product, this monopolist has to lower their price on all the goods they sell. They can't just sell the first one for $10 and the second one for $9.50 to somebody else. They want to sell two of them, they would need to sell them both for $9.50. And then we have our usual U-shaped cost curve. So there's that marginal cost curve, and finally we have this average total cost curve where the marginal cost goes through the minimum point. So don't forget our max criteria. They want to produce where marginal revenue equals marginal cost. So this is our big profit maximizing criteria, both in perfect competition as well as this monopoly. So that means we find out where marginal revenue equals marginal cost. Well, that's this point right here. So this is our marginal revenue curve. This is our marginal cost curve. We're going to figure out right where they intersect. So this is how much we should produce. Then we need to figure out our profit. So remember, profit is total revenue minus total cost. So profit is price times quantity, which is total revenue, minus average total cost times quantity. So this is total cost. If we take the average cost per unit, multiply it by how much we're producing, we're going to get the total cost. So if we can collect this term out here, so let's call it, in this case, Q star, since that's how we've labeled it on our graph. This is the area we're going to draw on the graph. All right, so the first thing we need to see is what's the average total cost per unit at this Q star. Well, we go from our Q star, we go up till we get to the average total cost curve. And this is telling us the average total cost at that level of production. So a lot of times on our graph and in class, we've just labeled that C. So that's the average total cost per unit when we're producing Q star. But now a monopolist gets to choose what price they want to set. They're not price takers like perfect competition. They get to choose what price they set. So what we do to figure out their prices, they want to charge us the most they can for producing Q star. They want to charge people the most they're willing to pay. And that's the height of the demand curve at Q star. Remember, the demand curve is like the willingness to pay. So we're figuring out what's the most people are willing to pay for that Q star amount of this good. So we go up to this demand curve and we get this monopolist price. So now we can figure out, we can just shade in what the profit is. So it's this area here. So this is the height. So this is this height of this rectangle, or the width, or whatever you want to call it. And Q star is the length. So we're taking this difference here, and we're multiplying it by this length, which is going to be this entire area here. So this is this economic profit. And it's greater than 0 here because the demand curve is above the average total cost here. So now in the long run, you could still make economic profit as long as there's still these barriers to entry. So this is what a profit maximization diagram looks like for monopoly when we have U-shaped cost curves.